This video covers section 10.2, solving quadratic equations by the quadratic formula. Objective 2, use the discriminant to determine the nature of solutions of a quadratic equation. In the video for 10.1, we saw that sometimes when you did the quadratic formula, like in practice 1, you ended up with these nice solutions. And that was because the piece under the radical, which we're going to call the discriminant, was a perfect square. We also saw that if it wasn't a perfect square, then we ended up with these square root problems, and those are what we call real but irrational solutions. So this time the discriminant, or the stuff under the radical, was a non-perfect square. And then what we saw was if the discriminant, or the stuff under the radical, was 0, we ended up with a single solution. And then if the discriminant's negative, we have these imaginary or complex solutions. So that's what we mean when we say the nature of the solutions. It's all about what do you get under the radical. B squared minus 4ac. So we give it a name and call it the discriminant. If the value of your discriminant is 169, positive in a perfect square, you get the two solutions and they're rational, or what I was calling the nice numbers. But if your discriminant is positive and not a perfect square, you still get the two solutions, but they're irrational. This is when you get solutions that have square roots in them. Then if your discriminant is 0, the plus or minus goes away, and you just have one solution, and they are real. Then when you get a negative discriminant, you get the two complex non-real solutions. So it's all about the discriminant. B squared minus 4ac. Negative 5 squared minus 4 times 1 times 3 is 25 minus 12, 13. So that would go under example 2, which would give us two irrational solutions. Letter B, b squared minus 4ac is 12 squared minus 4 times 4 times 9. 12 squared is 144, and 16 times 9 is also 144, which gives us 0. And when you have 0, you get one repeated real solution. And then the last case, I need to add 5 to both sides first. And then b squared minus 4ac is going to be negative 4 squared minus 4 times 5. That's looking like the negative one because this is 16 and this is bigger than 16. 80. And so this gives us negative 64. When it's less than 0, you get the two complex solutions that are not real. Here are 3 practice problems for you to try. I encourage you to press pause in your video and work these out, and come back when you're ready to see the solution. Now that you've had a chance to work these out, I'll work these out with you. Using the discriminant, b squared minus 4ac, we can determine the nature of the solutions. In this case, b is 5, a is 2, and c is 4. And this gives us 25 minus 32, which is negative 7. When this is negative, we get the 2 complex solutions that are non-real. And that's because we would be taking the square root of a negative number, giving us the i's. In letter B, we'd add 9 to both sides. And then we see that b squared minus 4ac is 12 squared minus 4 times 9, which is 144, minus another 144, which is 0. When the discriminant is 0, you have that plus or minus the square root. It becomes 0, so you don't have the plus or minus anymore, which just gives us 1 repeated real solution. And the last one, b squared minus 4ac. b is negative 4, a is 2, and c is 1. So that gives us 16 minus 8, which is 8. And so that's greater than 0, but it's a non-perfect square. So when you have a non-perfect square, you're taking the square root of something. It's not a perfect square. You end up with square roots, giving us 2 irrational solutions. So we see it's the discriminant that determines the nature of the solutions. And now what we talk about is we've seen 4 methods for solving quadratic equations. We can factor them if they're special, meaning if they're factorable. We can use the square root property. We can complete the square, or we can use the quadratic formula. But which ones do you use? Which one do you use when? If you can see that your discriminant is 0, it will factor. Or if you see your polynomial as being factored pretty quickly, then you can use the factoring method. I will use the square root property only if it's set up ready to go. The square has been completed for us. 3, completing the square. People only use this technique if the directions say you must use completing the square. And for all other cases, you use the quadratic formula. So here are 3 practice problems. I'd like you to try and determine which would be the most appropriate method to solve these. And come back and press play after you've done that, and I'll work these out with you. Now that you've had a chance to work these out, I'll work these out with you. This one is best or quickest done by the square root property, because I can see that I can divide by 5 and add 45 and get x squared equals 9, and then we take the square root of both sides and get plus or minus 3. Now, letter B, I never like to have a negative in front of my x squared, so I multiply both sides by -1, and that gives me 2x squared minus 5x plus 6 equals 0. Here my discriminant is 25 minus 48, which is less than 0, so I must use the quadratic formula. So we say that A is 2, B is -5, and C is 6. X is equal to the opposite of B, plus or minus B squared minus 4 times A times C divided by 2 times A. This gives me 5 plus or minus, that's 25 minus 48, which we already found, which looks like -23. All divided by 4. The I is going to come out of there, leave us with square root of 23, all divided by 4. 23 doesn't have any perfect square factors, so we leave it just like that. And letter C, we subtract 5 from both sides. And the discriminant here is 2 squared minus 4 times 3 times -5. And that's 4 plus 12 times 5 is 60. That's 64. Because that's a perfect square, that says that 3x squared plus 2x minus 5 is going to factor. So I just search around until I find these factors. This is going to be a -3x and a positive 5x. And so then I set 3x plus 5 equal to 0, or x minus 1 equal to 0. We get -5/3, or x equals 1. So the idea behind this is the quadratic formula is not always the easiest and most efficient way to do the problems. Square root property is very quick when you have the chance to do it. And factoring is also quick to do when you have the opportunity. But in the end, you always have the quadratic formula. And this concludes the video for section 10.2, solving quadratic equations by the quadratic formula. Objective 2, use the discriminant to determine the nature of solutions of a quadratic equation.